In daily life, to develop relations between quantities, we use three types of proportion: direct, inverse, and compound proportion. Direct proportion is a type of proportion in which one quantity increases or decreases, and then others will also increase or decrease with the same proportion. For example, the relation between pen and cost price is direct as both increases with the same proportion. Let's solve an example where a cow gives 5-liter milk and how many cows will give 15-liter milk. Step 1 identifies quantities, which are cow and milk, in this example. In step 2, write values under each quantity, respectively. In step 3, show relation with arrows. First draw arrow from unknown x to upwards and then relate second quantity with it. If they are directly related, the arrow will be in same direction. We draw arrow from unknown to upwards. Then by relating milk with cow, we see that if one cow gives 5-liter, it's mean that 15-liter milk will be given by more cows, so both quantities increases. The relation will be direct and arrow under milk will be in the same direction as the arrow under cows. In step 4, we write all quantities in their ratios. For this purpose, always write the number which is at start of arrow upside and the one which is at head of arrow to downside if ratio. As I have written x by 1 because x is at the start of the arrow and 1 is placed at arrow's head. By equating both ratios, we have x by 1 equals 15 by 5, which on division gives x equals 3. The second type of proportion is inverse proportion, in which one quantity increases, and the other will decrease with the same proportion. For example, to cover a distance, if speed is high, time will be less, or if speed is slow, then time will be high. So two quantities, speed and time, are inversely related. Let's solve with an example, in which 6 men completes paint in 4 days. Then how many days will take by 3 men? Again, doing the same steps as we did in direct proportion, but the difference is only in the direction of the arrow. If quantities are inversely related, then we will put arrow opposite in direction to x. Write ratios of quantities and then compare ratios to get value of x. Here we have known ratios 6/3 equals to unknown ratio x, 4. After division, 10 by 4 equals 2. Now take 4 to the other side, which multiplies with 2 and gives x equals 8. In compound proportion, we have proportion between more than 2 quantities. Understand this type with an example. 2 men built 1 wall in 3 days. In how many days 2 walls will be built by 3 men? Step 1, identify quantities. Then write values under each respective quantity. Draw arrow forms an unknown quantity to upwards. To develop relations, compared quantities to unknown quantity 1 by 1. 1 wall 3 days, then 2 walls will take more days, so relation will be direct, which is shown by arrow. While developing relation between men and days, we compare them separately as fewer men more days, and if men are more in numbers, then it will take fewer days, so relation is inverse. Now write ratios of all 3 quantities. Then we compare these ratios as they are given in some proportion. For this purpose, write known ratios to one side and unknown ratio to other side of equality. On simplification, we get x equals 4. In the second example, we have 3 quantities: men, apples and days. In the first step, we write quantities, and then under each quantity, we write its respective value. Put arrow from unknown x to upward and then compare other two quantities with it. As apples are in direct relation with men, so arrow will be in same direction, whereas days are inversely related to men, so arrow is opposite in downward direction. Write each quantity in its ratio form and after that equate known ratios with unknown. Always first write value, which is at the starting of arrow, and divide it by its value at arrow's head. In equation, we divide 2 by 4 and 6 by 4. We get x equals 1/2 times 3/2 times 4. After simple division, 4 cancels with 1/2 times 1/2, and we get x equals 3.